I also just realized I can just turn on my video, and then you can also just see me instead of looking at the big camera.
Yes. I mean, I know what you look like, but thank you. For those of you not familiar, I seem to meet Chrissy at PyCon every year, so this is not an unfamiliar sight.
Well, you got to know Calvin first, didn't you? Through the Startup Bro stuff?
I feel like we sort of met all the 6 feet uppers at once in a grand, overwhelming whirl.
Yeah, so last year at PyCon, my company kind of co-hosted this thing for this people at Startup Bro, and you were on Startup Bro a couple years ago, right, for PyCon?
Yeah, absolutely. That's how we kind of got our big start, and
yeah. So that's how I got to know Meredydd. And then, so we hung out a little bit then, and then that Sunday at PyCon, I was on my way to the Rock and Roll Hall of Fame, and I was going up the elevator, Meredydd was going down. I'm like, hey, you want to go to the Rock and Roll Hall of Fame? And he's like, yeah, let's go. So that was fun.
Basically how it went. And then this time there was a party in some bar in Cleveland with a whole bunch of like drunk college kids outside.
Yeah, crazy things happen at PyCon.
I guess we'll probably give it just a few more minutes.
Yeah, just a couple more minutes.
3 more minutes.
Alrighty.
Of course, it seems weird, and everyone can see me up on the big screen too. Just realized.
I feel like maybe we should dial in the meetings.
You could.
Oh yeah, you're in the corner there. Yeah.
Oh, that's cool that you guys use the 3D barcode. I tried to get my high school students to use the QR codes in PowerPoints. You know, you can just get a whole big link very easily, and they just fly so hard.
Yeah, I don't know how many people use that, but I just update the slideshow every month. So if you just have the link from before, then you can check it.
Like iPhone just natively can detect and open those up anymore. So, like with your phone, just pull up the camera and point it at the QR code, and it should pull up. I don't think you would have to connect to Wi-Fi if you have data. Yeah, there it is at the top of your screen.
If you use the Google camera, it will pick it up automatically. And if you use Google Lens, you can actually copy text or links straight off of this. I pulled up Google Lens and then copied the password into the Wi-Fi sign in.
Hey kids, whatever happened to red lasers?
Have you guys seen Google Translate in action?
I used it in Japan.
Yeah. I mean, you pointed at text and it translates it right.
I used that once at work when someone thought they got crypto wares because it was all in Russian.
Turn that as just a recipe for a good bowl.
Oh, yeah. No.
Russian.
It sounds like it. I was thinking more like a meat stick or something.
All right, well, I think we can go ahead and get started. I'll sit here because I'm in front of a mic. So I'm Chrissy, for those that don't know me, co-organizer of FayettePy. Casey here is the organizer. He's also the CEO of Lofty Labs here, where you are sitting. So if you have any questions about what Lofty does, you can ask him, but I can give you a hint. It has something to do with Python. I work for a company called 6 Feet Up in Indiana. I work remotely, but I live here in Springdale. So let's see if I had any announcements. Next month's meetup, I'm going to be the speaker talking about how to use PDB, the debugger for Python. In August, Dennis is going to talk. We haven't quite nailed down what he's going to talk about yet. And then in September, we'll do a hands-on night. So everyone bring your laptops and we'll work with Code Wars. Like we can do that in groups and play around with just creating like small things using Python. We also have a Slack group. So the Northwest Arkansas Developers Group created a Slack, and a bunch of us that are on there. There's a Python room. So if you have any Python questions, you can even hop on there and ask us any questions. All right, so the general program that we follow, nights that we have a speaker, we'll also do beginner tips. So we'll have someone that will just do a few beginner tips, because we tend to get a lot of people that come in that don't know anything about Python, but you just kind of want to see what it's about. So just to give you a little hint, or we get a lot of people that are just starting out. So I'm going to talk about dictionaries. So a dictionary is not just a book that has words in it to tell you what the meaning is, but a dictionary is a data type. Make that bigger. You can see I've got, there we go. So a dictionary, it's made up of key value pairs. So here's an example of one at the top. So I'm assigning it to a variable called instructor. And so the first key is name, and the value for that key is my name, Chrissy. Next key is handle. I put in CDW9. That tends to be what I use on Twitter and GitHub and such. And then I've also put in a location of Springdale, Arkansas. So if I'm looking at this in Python, so as you can see, I'm using the PDB debugger. You'll learn more about that if you come next month. But I can look at this dictionary and see, it returns exactly what I have there in the file. If I want to get a value, like let's say I want to get the name, this would be the syntax I use. So instructor using the variable name, square brackets, and then name is the name of the key that I can put in. And that's going to give me my name back there. So Chrissy, because that's the value for name. If I want to do another one, let's say age, what do you think that's going to do?
Name.
That's going to give me a key error because that key does not exist. But a way that I can kind of get around that, something that's not going to throw an error, is I can do instructor.get and pass that in, seeing if the key is available, which it is not. So then I don't get anything returned because it's just returning none. I can do the same thing to get the name, and there actually returns something. Let's say I want to set that to a default. So if I'm running some code that's going around some dictionaries, and it's going to check if age is there, and if it's not, then it can set a default value for me. So with the .get, I can pass in another parameter, and I'm just going to say 29, and that's the default. So anyone that doesn't have an age set in, they're just going to get 29. But if I actually want to set that, then I can do this just like I would be calling it, and then assigning an actual number there. So now when I look at instructor, the full dictionary, you can see now age has been appended to the end. And in this case, it is a number, whereas the other ones you can see, like Springdale, CDW9, they're all strings. Another thing that you can do is use set default. I messed that up. So in this case, I use set default, setting the location to Fayetteville, but that's only going to set Fayetteville as the default location if location isn't already there. So since I already had Springdale, my current city there, then that's what it actually returned. And looking at instructor again, I can see it has not actually changed that value. But if it wasn't there, so like in the next case, if I'm going to set a default for favorite color to blue, Now it has added that new key with blue. Now the difference here with what I did up here with setting the a default value of 29 is that didn't actually assign it to the dictionary itself. That's just what was returned, when I was trying to access that key in the dictionary. So let's look at some other things that we can do. I gotta stop selecting everything. So we can do .keys, assigning that to a variable of instructor keys. And so I'm using Python 3 here, and this is returning a dict keys object that has all of the different keys in it. So name, handle, location, age, and you can see this is all built, based on the dictionary that I've already built up, and not the original. If you were using Python 2 here, this would return a list. This is not a list, so if I try to access one of the values as if it were a list, I'm going to get an error that dict keys is not subscriptable. So it doesn't have indexes like a list would, but it is still iterable. So I can say, if I want to just do a quick list there, basically I'm just looping over everything in instructor keys and putting it in a list, then I actually have a list and I can get a value that way. If I want to get 0, then I get name. You can also just use list. I'm in PDB, so I have to do an exclamation point for that. And turn it into a list that way as well. You probably don't need to do that most of the time. I actually was reading about that and saw that doing it that way can be very expensive if you have a very large dictionary. So use it sparingly. And then similarly, you can also get instructor.values, which is going to return just all of the values of the dictionary. And .items is going to return everything, the key value pairs, but as tuples inside of a list. So as I pointed out, I guess we can see it here, some of the values are name or strings. This one's a number. We can also pass in lists or anything else. It doesn't matter. So if I want to put in the states that I've lived in, there you can see, then it just saves it as a list, just like I had passed it in. One thing to watch out for, so I'm using Python 3.7 here, and when the order of the keys that you put into the dictionary, they will stay in order. So like every time I look at instructor, it's always going to be in the same order, even as I add more items. But that if you're using an older version of Python, you cannot rely on that, because Python kind of decides its own ordering for that dictionary, doing it in a way that is going to be very fast. So you can't rely on the actual order of what you had set, because it's not going to stay that way. Dictionaries can be nested. You can have dictionary inside a dictionary, inside of a list, inside of a dictionary. Can anyone think of an example that uses that, something that you might see at least using Python or the web? Mm-hmm. Yeah, so I do. Yeah, I have an example here. So yeah, if you're doing requests online, doing pushing data, getting just getting data, it's going to look something like this. So this is an example payload from GitHub, and what it would look like. So it starts with a dictionary, and then it has more dictionaries inside of that. Sometimes there are lists in there. This one's fairly simple. I've seen some much more complex ones. Of course, most of the time it's not a Python dictionary, but it's the same type of structure in a string, and so you can do things with it to turn it into an actual Python dictionary. If you want to delete something in the dictionary, you use del and then a space, and then you can access a key. But in this case, this key isn't in there, so it's going to give me a key error. But instead, I can put the right one in there, and it will delete it. But of course, if I run that same thing again, now I'm going to get a key error again because I deleted it. And then if I want to completely start over and clear out the dictionary, I can use .clear. And now it's just an empty dictionary. All right, so that's what I've got. Any questions? Yes?
What exactly is val? Is that a function, or is that like a, what is it?
I don't know. Do you know?
It's a statement in the standard library, like an if statement would be, to unallocate.
Like to free up memory?
Yeah, I mean, you can use the.
Because everything on like Python's an object, so you
Right.
essentially break it up.
There are times where you kind of use a pipe managed garbage collection, but yeah, you can use it against other types besides dictionaries, but it's deleting the reference. And when the reference count to any value goes to 0, Python gets started.
Gotcha.
So I have a question. So I don't know whether I see it correctly or not. So when you are converting the keys to the list, in front of list you add the exclamation.
Oh yeah, so that's because I'm in PDB and because list is a keyword in PDB. And so if I just type list, it's going to be trying to use the PDB version and not actually Python's.
Can you use things that aren't strings as keys in a dictionary?
I meant to look that up. You can use integers. Yeah, I don't know.
You can, I was leading the question.
Yeah, well, I was going to try it.
I want to say no.
So, perfect example. You can use any hashable type. And lots of types in Python are hashable. Lists aren't one of them. But interestingly, an instance of an object is a hashable type.
Oh, okay.
So that means that you can actually use a reference to a function as a key to a dictionary, which means you can do really interesting things when you're iterating over keys or items and potentially calling the function from the key if the item is of a certain value for something. Or in Django a lot, we'll do things where we want to build some metadata around the list of model instances that we got back from the database. And so you might actually build a dictionary where the key is the model instance itself, and the value is some complementary value to that model instance.
Okay, I may have done that before.
It's probably from
Yes.
You may have mentioned it. I recall you said that object that is returned is not indexable. Is the dictionary itself call the value by index on it?
Let's. I don't believe that will work. No.
Because 2 is a hashable type. So it's
Right. So yeah, it's looking for a key of 2.
Yeah.
But you can loop over dictionaries.
We just do some list comprehension where you're looking for 2 or something.
Is it loading function?
So I have one question. I'm from Java background, so it will be the map will be using the generics like what type the key and the value should be. So do you have anything in the Python like that? The key should be specific type, data type. I should need to insert only string. I should insert only the integer. So something like that we have.
Is that, sorry, I couldn't hear the whole thing. Could you hear? I mean, was it like what Casey was saying, that it just needs to be a hashable type? So something, so an integer, a string, a float, or an object?
Yeah, I need only the specific type. So I'm creating a map, I'm creating a dictionary. So runtime, I may get different keys. So I just want to insert only the string. So can you explicitly specify
That the keys can only be of a certain type.
Yeah.
Not that I'm not at a primitive level with the dictionary. You'd have to wrap some sort of interface around it to do that.
Yeah.
I think
I think so too.
Yeah.
All right, well, I'm going to stop sharing and then we can hand it over to Meredydd. So any of you that weren't here missed his introduction. This is Meredydd Luff. He lives in England, so it is 1:30 in the morning for him, I think. Fortunately,
Good morning from the future, from tomorrow.
So he's going to be coming out of the speaker here, so you have to make sure everyone stays nice and quiet to make sure you can hear him. If you can't hear, like especially in the back, just bring a chair on, just come right on up here. All right, so Meredydd, I'll hand it off to you. You can go ahead and talk about Anvil.
Awesome. Well, thank you very much for having me. I am just going to take a moment of technical time in an attempt to share my screen.
Probably mute.
Okay, there we go. I am sharing. Am I also visible in the corner there?
You are. Yes.
Good, yes? Brilliant. Okay, so my name is Meredydd. I am one of the founders of Anvil. It's a tool for building full-stack web apps with nothing but Python. And today I'm going to talk about what Anvil is, how it works, and kind of why we did it that way. But first, you might want to ask, well, you know, why would you want to change how web development is done? So just as a quick check of hands, how many people here do build web apps? Yeah, okay. Couple of hands, many people not. So if you don't do this on a regular basis, you might not be familiar with the amount of complexity that's involved in creating one of these things. Think about it from the perspective of your data. If you're building a web application, your data goes through a ton of different forms on its way through your application, right? A typical application, the data probably starts as rows in a database table accessed by SQL. You then convert these into objects on the server, probably Python objects in present company, and they are accessed by methods and attributes and so on. And then you immediately turn around and turn those objects into JSON, accessed over HTTP REST endpoints with this really weirdly limited set of verbs like get, post, put, and delete over a bunch of different endpoints. But on the other end of that HTTP connection is some JavaScript, which reassembles that data back into objects with a different set of methods and attributes. And then you have to turn that into HTML DOM objects, and then you use CSS to style that into pixels, and that is a lot of transformations, right? There are lots of different forms for your data, and you need to transform it all the time. It's what a web app spends most of its time doing. And that's tedious and repetitive. And that tedious and repetitive process attracts the wrong sort of magic. What do I mean by the wrong sort of magic? Well, I'm going to explain by taking a totally unfair pot shot at SQL Alchemy. Who here has tangled with SQL Alchemy? Yeah, okay. One or two hardy souls. So for those who aren't familiar with it, SQL Alchemy is it's a library for accessing rows in a database table as Python objects. And this is a totally unfair pot shot because it's actually really cool. It lets you write code like this. You know, query book, filter, book.price is less than 20. This is querying a database table called books or book. And you get to write it as a Python expression and returning Python objects. And that's nice. But the process of turning this, there we go. The process of turning this Python expression into SQL you can execute against a database is black magic. We're talking meta classes. We're talking overriding completely normal Python operators to do something completely different to what they normally do. If you thought this was a comparison between two numbers, you're in for a shock. It's actually a weirdly arbitrary piece of Python that generates source code in a different programming language. This is weird. And it's kind of cool if you do it once. You know, you can get away with it once. But if you do this kind of magic at every level of this stack, you are going to be in for a bad day. But of course, that's exactly what we do. We have ORMs like SQL Alchemy turning database rows into objects. We have REST frameworks expressing those objects as HTTP endpoints with JSON. We have JavaScript frameworks on the other end, like Angular resources, reassembling those HTTP requests into JavaScript classes. We have templating engines that turn that into HTML DOM, and we have CSS frameworks to turn it into pixels. And every one of those transformation layers has two properties. One is that it's kind of gunky. They all abuse the syntax or semantics of one layer to represent an adjacent layer, like how SQL Alchemy had kind of twisted Python expressions to represent something generating SQL source code. You know, they all do this, and that means that they are brittle. If you wrote a program that assumed that this comparison was actually a Python numerical calculation, it would break. They're brittle. You need to understand how it works underneath before you can use them at an expert level. And this creates an enormous amount of complexity because you need to know all of these things and all of these things in order to get anywhere at all. Well, we're Pythonists here. How does that compare to PEP20, the Zen of Python? These popular principles, you've heard them, simple is better than complex. What we just saw there was not a simple system. That was complex as they come. If the implementation is hard to explain, it's a bad idea. Again, think about the inside of a JavaScript framework, or don't, because it'll give you nightmares. Those are not simple systems. It's not easy to explain how they work. It's not easy to understand how they work, but you need to in order to use them. Finally, here's a famous one. There should be one and preferably only one obvious way to do it. Oh boy, right? So if this system really is as complex and unPythonic as I hope I've convinced you it is, how could we do it better? Well, here's our answer to that question. We take all these different representations and all these different frameworks, and we say, actually, we should replace that all with one representation, and that representation is Python. So instead of this HTML and CSS business, we have a visual UI builder, so you can drag and drop a user interface, and all the things you drag and drop are actually Python objects. Instead of writing JavaScript in the client, we write Python. But then that means that instead of creating altering our interface by generating source code in a different programming language, we just make a function call to a Python object. We run Python on the server, of course, but now we have Python on the client and Python on the server. There's no reason to mash all our data into JSON and HTTP endpoints. No, we just make a function call. We even have a Python native database where the tables and rows are just Python objects you can pass around in your code. And so instead of these 6 different representations of your data, everything is Python objects all the time, and you only need to know one language. So that's the theory of it. Let me show you how that works in practice. So, important question. Oh, let's shrink this down a bit. Can you see my screen?
Yes. Yes.
Yes, we're good. Okay. So, this is, hang on, there we go, let's bring that in a bit. Okay, this is the Anvil website. I'm just going to show you how Anvil works. I'm going to just build an example application. So I've logged in, I'm going to create an app. I'm going to choose a visual theme, so this is material design. And here I am in the Anvil editor. This is a web page. And this is a toolbox of things I can add to that web page. So I'm going to start by building, well, put some text on. So I'm going to take a label component, put it into the title bar, and then you can see I've got this label. I can change its properties, including what text is on the label. And that's how we put some text onto our page in Anvil. Pretty straightforward. I'm going to do something a little bit more interactive. I'm just going to build you like an interactive hello world. So something where we prompt the user to enter their name, and it greets you by name. So we're going to want a text box for you to answer that question. So what's your name? I've dragged and dropped a text box onto the page. I'm going to call this name box. Everything in Python has everything in Anvil has a variable name, so we can access it from code. We'll see that in a moment. So when you've entered your name, you'll want a button to click when you're done. Okay, to make the text on that button say hello, make it a bit more prominent. And you can see what's going to happen here, right? The user's going to enter their name, they're going to click the button, and a message is going to appear. So the final thing we need is a label here for the message to appear on. We're going to call it message label. And we can edit some more text properties. So we can make it centered, and we can make the font big, and so on. So we've just built our web page, and that was an awful lot faster than we could have done it with HTML and CSS. But the really cool thing is everything here is backed by Python. So if I double-click this button, I'm now editing the Python code that runs when that button gets clicked. And all the things I dragged and dropped onto my page, you can see are available as variables in my Python code. So if I want to update the text on this message label, we start out blank. If I want to update the text on that message label based on the text in the name box, I can just go self.messagelabel.text equals hello, self.namebox.text. Easy. So if I run this, let's give it a name, hello, and enter a name here, click the button, we've just built an interactive web app. In fact, it's already online. This is its URL. So this is like a Google Docs sharing URL. So it's private. If I send you the URL, you can get to the app. If I don't send it to you, you can't guess it. Let's make it public. Right, that's it. Hello, FayettePy.anvil.app. I could click on that link. You could get your phone or your laptop out right now, go to this address, and this app would be live. So we just built and published a web app with nothing but Python in a very, very short period of time. Now, so far, everything we've done is actually happening in the web browser. Even this code gets compiled to JavaScript and it runs in your web browser as you visit the page. Happy fast responses. But of course, any app of any serious size is going to require some server-side code as well. So we can add a server module. And this is an ordinary Python module where the code runs on our servers. Ordinary Python module, ordinary Python function. Right, it takes the name parameter and then it prints hello and then that name. So far, so ordinary, right? But what we can do is we can tag this function anvil.server.callable. And that says that this function on the server, we should be able to call it from the browser. So if we go back to our browser code, as well as when the button gets clicked, as well as updating the user interface, I can anvil.server.call, and I can call that say hello function. So we can see it wants one parameter, the name. So I'm going to pass in the text from that text box. And now when I run this, you can see we've got some output in the logs. Right, that print statement on the server was running. So now we've got code running on the server being driven by this user interface we've just built. And now we're seriously in business. Because, of course, this stuff is running in the browser. It's compiled to JavaScript. There's limits to what you can do, right? You can't open files from the browser. You're not going to be able to run NumPy in JavaScript. But over here, this is a real Python. I'm sorry. This is a real Python 3.7 environment. I can use the full set of Python modules. I have a database I want to connect to. Import PyMySQL, import CyclePG2, connect to it, go. I want to do some numerical computation, import NumPy, go. I want to plot a graph, import Matplotlib. We now have the full Python toolkit available, and we can connect it to web apps that we can drag and drop design and deploy really easily. Now, in practice, the first thing everybody asks is, so how do I set up a database? And so, although you can use one, if you already have it, you just use the standard Python modules for talking to it. We actually have a built-in database called the Data Table Service. Let's show you how that works. I'm going to create a table to store all the visitors in my app. So this is actually backed by Postgres, so it's a real industrial strength database. You can put terabytes of data into this thing if you want. We're going to be a little bit less ambitious here. We're just going to want a text column to store the name, and maybe let's go with a date and time column to store when that name was entered into the page. So that's it. We've just built our database. This table is called apptables.visitors. That's its variable name. So we can access it from code, just like we could access those text boxes and buttons from code. We can access the data tables from code. So let's go to the server. As well as printing that message, I want to record this visitor. So I can take apptables.visitors, that table we've just created. I can add a row. I can fill out the name column with this name we've been passed in from the browser. I'll fill out the when column with datetime.now. If I run this, can anyone spot my error? No, I haven't imported datetime, so that's a classic. Yeah, oh, sorry. Chrissy didn't quite get to the microphone in time, did she? So if I run this, sure enough, it's going to blow up, right? Name datetime is not defined. I can go right to the line of error where that line of code where that error occurred. In fact, I can see a full stack trace. I can see where in the web browser that was called from. So I can see exactly how we got to that error situation, and then I can go and fix it. So let's fix it. Again, if you're people who do web development, you'll be familiar with the fact that this is not normally available to you. You have to grub through several different log files to work out what blew up and where. This is significantly easier because it's all one language. It's just a function call. But now I fix this. I can now enter a couple of names. And because that code was running, we can see we've added that code, those lines to the database. So we've just built and deployed a database-backed web app with nothing but Python in still a very, very short period of time. I'm going to show you one more thing, which is how we can display some of this data on our page. So what I want to do is I want to take this table of visitors and I want to display it on our page. So the first thing I'm going to do is I'm going to go to our server module. I'm going to make a function we can call to get all our visitors. And what we're going to do is we're going to return this table, apptable_visitors.search. So this just searches through the table. We can apply some query expressions, but if we don't specify anything, this will just be a iterator that goes over the entire table. So now we have something on the server to get that data. We can go back to our client code and we can display it, or at least we can display it if my internet connection starts, there we go, behaving itself. So we're going to put another card on here. We'll put a headline on it saying previous visitors. And I'm going to add a data grid. So it's a table of data. And we can see we have a couple of columns, right? So we're going to have the name. That's going to pull the name column out of these rows of the database. And we have a when entered column, and that's going to pull the when column out of the database. And we don't need column 3. So we can adjust these, make the when column nice and narrow. All right, and that's it. So we've just built a table, the grid to display our data on. Inside this is a repeating panel. So this is a component that has an items property. So you give it any list or Python iterable thing, and what it will do is it will repeat this chunk of UI for every element in that list. And by default, that'll just display those columns. So what we want to do is set the items property of this repeating panel to a list of rows from the database. So we do this in the init method. So this runs when the page is being constructed. And we just go repeating panel 1.items, set the items property equals the return value of Anvil server call get visitors. So we call that function and put its results into the repeating panel. And what do you know? We are displaying the previous visitors who've entered their names. You can see we have the names and we have the date times where they're displayed. Sorry, when they were entered. Now, by default, we're just calling stir on these things. So the default formatting of a date time is kind of ugly. So let's go in and fix that. Let's format those dates nicely. So again, we're going to edit the template. So this is the thing that gets displayed for every row, every item in that list. By default, we just display the when key from this. It's a like dictionary type object, but we can actually customize that. We can say, well, in this column, we want to display a label. And we can add a data binding. We can say that the text of this label is set to self.item. Now here, self.item is this element in the items list. So this is an object representing a row from the visitors table. And we can look up columns in that row, just like a dictionary. So actually, I don't want to display the name. I want to display when, which is a datetime object. And this is just a Python expression, so we can just call stirftime on it. There we go. And now when we run this, we'll call stirftime for every date here, and we can see a nicely formatted date. So you can see that it's really quite straightforward to build and deploy a database-backed web app that puts data in, takes data out, displays it, again, with nothing but Python, with your user interface drag and drop. One language, one representation. I could demo this all day. There's a lot more that I can demo, but I just wanted to give you an idea of what Anvil actually looked like to use. And having shown you how it works, I'm now going to go back and talk a little bit about how it's built, how all of this works under the hood. I have a few things I'm going to talk about. We should have time for all of them today. So the first sort of part of how it works that is really obvious and in your face is that we're running Python in the web browser. And obviously, if you're running something in a web browser, it has to be JavaScript. And so we compile Python to JavaScript and it's in your browser. To do this, we use a Python to JavaScript compiler called sculpt.org. And it's a really neat tool. You give it a Python expression, and it will compile it into a chunk of JavaScript that will do the same thing as that Python expression. And make a new stir object in this case. You give it a Python function, it will produce, honestly, the ugliest JavaScript you've ever seen, but it will produce a JavaScript function that does the same thing as that Python function. And this is great as far as it goes. But JavaScript, in its infinite wisdom, is a 100% non-blocking language, right? If you want to do some piece of from long-running computation, go check something from a database, go make a request to a server, you're going to have to use callbacks, and that's kind of ugly. Just to give you an example, right? Here's some code that you might want to write in Python. It's a very straightforward pattern, right? Go get something from a database, and then do some computation on it. Here's how you do the equivalent thing in JavaScript, right? I count 1, 2, 3 different callbacks. And in case you think I'm being unfair to JavaScript here, this was literally copied and pasted from the first page of the Postgres JavaScript API documentation. And sure, there are techniques for doing this better in JavaScript. You can use, futures rather than the marching callbacks, but you're still going to have to understand a whole bunch of complexity that you really shouldn't need to be dealing with to do an operation this simple. But the good news is we have a Python to JavaScript compiler. So why don't we see if we can turn something like this into something like this automatically? So we check out the Sculpt source code and we get exploring. It turns out that Sculpt has a classic compiler architecture that's unsurprisingly based on CPython. What you do is you take this expression, you tokenize it and parse it. By the way, these are the names of the source files in the Sculpt source if you want to follow along. You end up with a bunch of chunks of text that are sort of meaningful to Python, and then you assemble this into what's called an abstract syntax tree, which is a tree of operations, right? We have an assignment. We assign the variable results to the result of a function call. We call the function f, and we pass them this argument. And this is a tree of operations that, are the sorts of operations that make sense in Python. And then we have a compiler that walks across this tree, emitting JavaScript code. And so, pretty clearly, this is what we're going to have to modify if we want to turn blocking Python into non-blocking JavaScript. So it's kind of tricky because we're compiling Python functions to JavaScript functions. So they're JavaScript functions, they have to return, but we want the Python functions to block. So what we do is we invent a new type of return value that a function can return to say, I'm returning because I have to stop now, but actually I'm not done, I'm just blocked. And we call this a suspension. So what we do is for every call of a function, we generate code like this. So we do the call, and then we check, hang on, did that function actually return, or did it return a suspension? Because if it's blocking, if it returned a suspension, then what we're going to do is we, in this function, are going to save all our states. So save all our local variables, save our temporaries, save where we are in the function, and then we're going to return our own suspension that incorporates this suspension we've just been given. So here's an example to show how that might work. So we have this function that calls a potentially blocking operation that runs when a button gets clicked. So the button gets clicked, that gets called from the JavaScript runtime. We're calling the button click function, we're calling the get function, and that calls to the database, and that suspends. Well, the get function realizes, hey, that function hasn't returned, I've been given a suspension. So it saves all its locals, saves all its temporaries, and returns its own suspension, wrapping that. And button one click realizes that the get method has suspended. So it also suspends, it saves all its locals, saves all its temporaries, returns a suspension, and the JavaScript runtime sits on it. And so a few milliseconds later, when the database comes back with an answer, we can resume this suspension. So what we do is that jumps back into the button one click function, it restores all the local variables, it restores all the temporaries, and then it resumes the inner suspension, which jumps to the right place and restores all the locals and restores all the temporaries, and resumes that suspension, which jumps back into the database code, and the database goes, oh, well, I've got some data now, return. Reinflated our JavaScript call stack of JavaScript functions that are compiled from Python functions to resume this code. And so that's how we turn blocking Python into non-blocking JavaScript, so you can write simple code like this rather than hairy callback code. Sculpt.org is the website of the project. Come help us out. I'm one of the maintainers now since I made that big change. Do come and join in. We're always happy for help. Let's talk about something else that's big and noticeable in Anvil, right? You saw me when that button was clicked. I just made a function call from the browser code to the server code, like it was the easiest thing. This is an awful lot easier than assembling an HTTP request and mashing all your arguments into JSON and unpacking them at the other end. It's just a Python function call, right? You've got positional arguments, you've got keyword arguments, you've got return values. It's an awful lot nicer than HTTP. How do we implement this? Well, it's a remote procedure call, so protocol over WebSockets. And the arguments and return values are encoded as JSON, which is fine for a call like this because everything in this call can be encoded into JSON. But what about things that can't be encoded into JSON, right? Like database rows. You saw me in that example. I was passing around database rows from the server to the client and then operating on them directly in the client, right? Pulling out row values and calling serif time on them and so on. We want to be able to pass things that aren't just JSON objects. So the way that Anvil handles this is, just to illustrate what's going on, right? We want to be able to do things like this. We have a row in our database. We want to be able to pull out rows from that database and just return them from server functions and just get those as return values, right? This is a thing that we want to be able to provide. This object that is a database row can just be returned from a server function, no problem. Now this can't be encoded as a JSON object, so we make a special type of thing that you can pass between server and client like this, and we call them live objects. Live objects have a few properties. They represent a server-side resource. So, for example, that object, that person object, is that row from the database. You know, sure, any client-side state it has is just like a cache for performance. That object is the database row. We want it to be secure, and specifically, just because we could return, you know, the server can return a row from the database, doesn't mean that the client code, which remember is running in your browser, it's not a trusted environment, that doesn't mean the client code can access all rows in all tables of that database. So what we have is this idea that possession is permission, or also known as a capability model. What we want here is that you can access, if the server has returned you an object, like a database row, to the client, you can access it. That was it giving you permission. But if it hasn't returned one of these objects, you can't access any rows that you haven't seen. So possession is permission, also known as capabilities. And how we implement this is that every live object has a few things. It has an identifier. So the identifier says, hey, this refers to this row of this table. It has some set of methods you can call on it. So, you know, update the row, delete the row, get item and set item. Because this is Python, implementing those methods allows us to access things via square brackets like dictionaries. And it's got some set of permissions. In this case, this is read-only. But then what it also has is a signature over all of this data using a key that only the server knows. And what that means is that if the client passes a live object back to the server, which, you know, is involved, say I make a method call on that object, it passes back all this information, including the signature, and the server checks the signature. And if that signature matches, we know that the client hasn't tampered with this object. It hasn't, you know, changed it to point to a different row or changed its permissions. And it knows that because the signature was right, only the server knows the key. We must have given the client access to this object. So they're allowed to make method calls on it. So that's how we implement this possession is permission thing. Here's how that caches out in practice. So if we return a database row from a server function, that means that the client is going to be able to access that. So we call this getPerson function. It goes and conditionally, depending on whether the user is logged in, that this is using our user authentication thing. I haven't shown you. Maybe I'll have time to show it later. But conditionally, if we're logged in, it might return us a database row. And then when that database row is returned, we can access it. We can do read-only things to it. If you just return it, I've returned you this object, you can look at it. We can actually be more clever than that. We can change our permissions. We can say, actually, if you're logged in, I want the client code to be able to write to this database row. So here we get the getPerson function. If we're logged in, it takes a client writable version of the people table and searches that. And what that means is that this person object, this database row, is a live object. You can update it from the client. And this is now very powerful because it means that you can write code that's, you know, running in the browser that's, you know, that triggers when you click a button to do your database object. You don't database update. You don't need to plumb every change through these 6 different layers. You can implement it once. You know, you can do your database updates from your button click handlers and not have to write a corresponding piece of server code every time. We can be even cleverer than that. We can delegate like a whole chunk of a table. So the important thing to know here is that data tables themselves are also live objects. We can pass them around. So what we're doing here is this is a function that gets records. So all the records for a particular user. So it gets the currently logged in user. If the currently logged in user, if we are currently logged in, then we take the records table, we return a client writable view on it. So it's a client writable version of this table, but only containing rows where the owner column matches the currently logged in user. And so what this means is that we get something that quacks like a database, like a data table. We can call this function. We get an object we can call add row on. We can search it. We can update it. But it's restricted to only rows where that are owned by us. So I've happily delegated to the client code all these database operations, and safe in the knowledge that this line of code restricted it to only rows accessed by owned by this user. So we can securely delegate access to a whole bunch of whole swathe of our data at once, which means we only have to write the update or add rows functions once. We can do it in our client code rather than having to write it 5 times at different points in our stack, and that makes it much easier and simpler to write these applications. Let's take a slightly more fun example. Let's talk about the uplink. So this is an example of something I'll talk about a little bit later, sort of escape hatches. The uplink is a way of making your Anvil app interoperate with code that's running outside Anvil. So how we do this is I'm going to switch back into my, there we go, into my Anvil app. If I activate the uplink is a library I can pip install anywhere in the world. And if I enable the uplink for this app, I get an authentication key, and I can, again, on my computer, wherever it's running, I can import anvil.server, I can anvil.server.connect with this authentication key, and then my code, wherever in the world it's running, is as if it's running in a server module on Anvil. And this means that you can do things like accessing the database tables. It means you can call server functions. It means you can make callable functions. So here's an example. I'm going to share my entire desktop here. Okay, so here is a. Can you see this terminal I've got here? Yeah. Good. Okay. Right. So let's activate a virtual environment. I'm going to pip install Anvil uplink. Again, this terminal is running on my computer in front of me right now. It's not running in the cloud. But if I start a Python interpreter and execute this code here, my computer has just connected up to Anvil. It's now connected to my app. I can now access my apps things from my terminal right here. Right, so app tables. I can access my tables. So let's see, how many rows do we have in our visitors table? 2. So I've just queried that database from my terminal over here. Let's make a callable function. Let's imagine that running here on my computer, or maybe on a corporate network that only this computer's on, I have some data source. So let's say I want to, I have some database I can query, and I want to write a web app that uses data from that database. I think it seems like a fair enough thing to do. What I can do, I don't have to expose this whole database to the world. I can make an uplink, a script that connects using the uplink, make a function that gets some data, and yeah, obviously here I would access some local database. I'm just going to return some data. And now this function can be called from my code. In fact, I'm going to redefine this function to print fetching data, so we can see when that function runs. Okay, so if I go back to my code, to my Python code here, I want to plot that data. I'm going to stick a card onto my page. I'm going to put a plot onto that page. And in the constructor here, I want to plot some data. I'm just using a Plotly API. I just set the data on that plot to be a scatter plot whose y values are calling that getData function. So I'm just going to call a function on my desktop from the cloud and plot the results. And if we go back to this terminal, we can see that function's triggered. So this is very powerful and lets you sort of reach out of our server-side environment. We have customers who, for example, they do ad tech and they have, big machine learning jobs on clickstream data. And so they run this on big machines out in Amazon EC2 with a whole bunch of GPUs in them. And they can connect that via the uplink to their Anvil app and have all the control panel implemented over here in Anvil. And the big beefy compute is connected to their app, and they can kick it off from there. So yeah, very powerful, allows you to plug arbitrary stuff in. Yes, was that a question?
Yes, I noticed you're using Python 2.7 locally. What are you using on the Anvil site?
Oh, right, sorry. This is 2.7 locally. That's just because that's what I got when I typed Python at my top prompt. This works just as well in 3. So this is, I have selected a full Python 3 environment. I'm currently using 3.7. This front-end code is compiled with Sculpt, which currently only supports Python 2, although we landed the pull request to move it to the Python 3.7.3 grammar on Monday, so that is changing very, very soon.
All right, cool.
I could give a whole talk about how that migration was done, and I may do one day, but not today. Okay, so how that works, by the way, given that I'm talking to you about the uplink, how that works is that the uplink library just makes a WebSocket connection up to Anvil, and then it speaks the same RPC protocol as we speak between the client and the server, and it supports the same live objects, which is why I could do those direct manipulations to the database. It's just the same protocol. All right. Couple more how it works things before I start talking about deeper design questions. So sandboxing. This is a challenge. You saw, right, all the things with white backgrounds, we compiled to JavaScript ones in your web browser. All the things in the yellow backgrounds, they were running on our servers, which means that we're in the business of running people from the internet's code on our servers, which is a scary prospect. In fact, it's worse than that, because everything I'm doing right now, you can do on everything I've shown you, you can do on Anvil's free plan. And we love having a free plan. It means that people can use it for education, people can use it to play around, people can use it to build silly small apps. But it does mean that we are in the business of running random strangers from the internet's code on our computers, which should make you very, very nervous. Just to go over why this is a problem, right? When you run a program using a Python interpreter, you take a Python interpreter and you load your script into it, and then your interpreter will do exactly what that script tells it to do. If your script tells it to systematically walk across the file system and delete every file, that is what the Python interpreter will do. Because, that's how programming languages work. So this is very trusted input. And there have been a couple of ill-advised attempts to try and make the interpreter safe, for untrusted code, to limit what modules you can import. And the thing about CPython, the Python interpreter, it built to trust this input. It is not built to constrain what code can do. It's built to enable what code can do. And so these supposed sandboxes, they always, they haven't thought of everything. There's always a way of working around the corner, getting a handle on some high-powered library like OS or sys, and going bananas all over your file system. So we absolutely don't want to load random people's scripts into a CPython interpreter running on our servers. Bad idea. Or if we do, we want to stick it inside a Docker container, inside a virtual machine, inside a lead-lined box, and stand 10 feet away from it. So how we solve this? We use something called PyPy. Who here is familiar with PyPy? Anybody? Oh, right. Oh, okay. 1 or 2. So PyPy is a really cool thing. It's a Python interpreter written in Python. Hence the snake eating itself logo. It's a little bit weird, right? You'd think, what use is a Python interpreter written in Python? Because if my Python interpreter is written in Python, well, I'll need a Python interpreter to run my interpreter, and then I load my actual code into that, and it's going to be interpreted by an interpreter that's also interpreted, and it's going to run dog slow. And sure enough, you can run PyPy like this, and if you do this, it will run incredibly slowly. But PyPy is not in fact written in Python. It is written in RPython, which is a subset of Python that can be compiled to native code. So there's an RPython compiler that will take PyPy and produce a bunch of machine code. And now you have a Python interpreter in machine code that you can load your script into, and it runs at a decent speed. In fact, significantly faster than CPython most of the time. Okay, so you might think, oh well, we're back at square one at this point, right? We're loading a script into our interpreter. This is very trusted input. If our script says to delete every file on the file system, the interpreter will do exactly that. And yes, you're right. This on its own wouldn't help. But the crucial thing here is that the PyPy interpreter is now written in Python, not C. It's written in a memory-safe language. C programs, basically every C program, is vulnerable to memory corruption vulnerabilities. You can seize control of the program, inject your own code, and make that process execute any code you want. By and large, programs written in C should not be handling untrusted data, let alone stuff it's not really configured to be resistant against. But this is running in Python, which means that every CPU instruction executed by this PyPy interpreter was put there by the Python compiler. It's very, very unlikely someone's going to be able to break out and write new code. And what this means is that we can enforce constraints in the RPython compiler about what this program does, and be reasonably confident that those constraints will be obeyed. And so what we actually do, there's a sandbox mode for PyPy that refuses to emit system calls. Now, if you're not familiar with how this works, this is kind of the low level how a program runs on an operating system. So when you run a program on an operating system like Linux or macOS or Windows, it doesn't actually get full control of the hardware. It actually executes in a virtual memory on a virtual processor with, it does not have direct access to things like the disk or the monitor or the keyboard. What it does have is the ability to make system calls, and these system calls are polite requests to the operating system kernel, which is really the monarch of the machine. And those system calls are things like, could you, open this file, please? Read some here, write some data here, connect to that network address. And the operating system is responsible for making all that happen. But what we can do is the sandboxing RPython compiler actually refuses to emit the code, to generate the code that would make system calls. Instead, every time it would emit code to make a system call, say open a file, it instead emits code that makes a polite request on standard output saying, hey, I'd like to make this system call, please. Please tell me what happens. And we plug this into a supervisor process that simulates the results of each system call. So we put this thing into the matrix. It works in an imaginary environment with an imaginary file system, and actually has very little it can do. If it asks to delete a file, I think actually the supervisor will go, I don't actually understand the unlinked system call, and kill you. So what that means is that these things are not going to execute any system calls apart from reading and writing to standard output, making requests to the supervisor process. And the supervisor process is pretty trustworthy. It's written in a memory-safe language as well, and it's doing some very simple things. And what this means is that these things aren't going to mess with nearby processes. So we can run tons of these things in the same Docker container, and that's much more efficient. You can run lots of processes next to each other. It's much more efficient than running, a virtual machine, and they take, hundreds of megabytes of memory each. And so this means we can serve lots of different free users with processes running next to each other in an efficient way, and that makes it cost effective for us to allow any random free user to run code on our servers for free by the magic of writing Python interpreters in Python. There are a couple of caveats to this. The first caveat is that actually an awful lot of the Python modules you'll want to use are written in C, and as we heard before, you should not trust programs written in C with untrusted data. So things like NumPy, we can't actually use from the PyPy sandbox without compromising it, which means that there's a whole bunch of modules you can't use on the free plan, which is kind of sad. The other sad thing is that the PyPy sandbox is currently Python 2 only, which, yes, again, we're working on getting that fixed. We still have another year before Python 2's end of life, but it does mean that free users are currently stuck in restricted Python 2. But paid users, of course, if you're paying us, we can afford to run a virtual machine for you. And so paid users get a full Python 2.7 or 3.7 environment. But yeah, that's how we sandbox to be able to offer something worthwhile to free users. And so, you know, actually, restricted Python 2 is perfectly adequate for example, teaching or for hobby stuff. And again, if you want to use advanced libraries, you can always connect in with the uplink from your own server and run your own code on your own machine, and that's perfectly fine. So the last part of the how it works is possibly my favorite part of Anvil, which is the autocompleter. You saw as I was doing those demos there, as I was typing, it was offering me, you know, autocompletion of attributes and methods and so on. And if you don't use autocompletion on a day-to-day basis, I really recommend it. It is great. Autocompletion is important because it gives you discoverability. It lets you, you know, see what methods are available in your APIs without having to page over to the documentation. It gives you speed because, you know, you could type 3 characters and hit the tab key rather than typing out whole variable names. It gives you confidence that what you're doing is right because there are whole classes of bugs that you can fix without even hitting the run button because the autocompleter has told you, no, that method's not spelt like that, or this value isn't the type you thought it was. And for all of these reasons, it just makes you, it feels good to use. How many people here use an environment like PyCharm that has autocompletion as a day-to-day basis? Who here programs in PyCharm? Yeah, okay, bunch of people. Who here uses like Emacs or Vim or Sublime Text? Yeah, okay, 1 or 2 people. You usually get some diehards. To the diehards in the audience, my message is, don't worry, you can have autocompletion too. Even in Vim, there's a plugin to use a Jedi autocompletion engine. There's also a couple of others. If you don't use autocompletion today, if you take one thing away from this talk, try it. Try using an autocompleter for 2 weeks. I promise you it will change your life. So these things are available off the shelf, but unfortunately something like Jedi was not actually suitable for what we're doing with Anvil. It's 2 reasons. One is that Anvil's a full stack service. So, you know, your autocompleter, you saw it knew about what was in my database, it knew about what was running on my server code, it knew about what was in my client, it knew about what components I dragged and dropped in the drag and drop designer. And that's not fatal. You know, we could have hacked that into something like Jedi. But the really important thing is that Python is something you use from a web browser. And Jedi or something like it, they expect files on a file system. We pretty much have to run those on the server. And when you hit the tab key, there is just not enough time to go back to the server, parse all your code, work out what the autocompletions are, and send it back to your browser. Just not enough time. So we had to implement our autocompleter in JavaScript. And you'd think that would be fairly hard to work out what options to provide in your code. But of course, we have a Python to JavaScript compiler lying around. And we've already seen how we can use that to turn blocks of Python code into abstract syntax trees of Python operations. And so that's what we do. When you hit the tab key in Anvil, we take the module you're currently editing. We put it to sculpt. We make an abstract syntax tree. We've replaced where your cursor is with a random symbol that we're not going to confuse with anything else. And then we take this abstract syntax tree and we walk through it. And we can walk through it building up an idea of, for example, like what variables are defined at every point in the code. And then when we hit, the variable name that is your cursor, we can say, oh, well, what variables are in scope at this point in our code? And we can offer them all as autocomplete options. Of course, we can autocomplete a lot more than just what variables are in scope. Here's an example. We're autocompleting, what things you can look up in a dictionary-style object. But to get here, we actually inferred through a lot, right? We've worked out what type you get when you call this function, and then we've worked out what type of thing you get when you iterate through that value, and then we've looked at, hey, what do you get if you look up the email key, and the answer is you get a string. So we can follow this through just by walking the abstract syntax tree and doing a little bit of simulation. It's actually not that hard. Speaking of function calls, of course, we don't just want to walk the return values from functions. We also want to autocomplete the arguments to functions. So here's an example. We have this server function, say hello, and we call it with a particular type of argument. And here, when we're editing the server code, we want the autocompleter to know what's being passed in. And so what we do is, of course, when we parse a Python module, we store the top level scope. We store what variables and functions are defined in that module. And so that when somebody imports that module from somewhere else, we know, what you get when you import it. But as well as functions we define, we also, when we parse a module, we store what functions you've called. So here we see, they've called anvil.server.call, they've called the say hello server function, and they've called it with this type of argument. And so we stock that away, we store it. And then when we're over here parsing this server module for autocomplete, we can see, aha, we are inside the say hello server function. And I know what type of argument that's called from, and so we pluck out the first positional argument to this function is this type, and we dump it into the local scope where it autocompletes. So we can autocomplete an awful lot of types of variables that are passed around. We can autocomplete a lot about these data types. In fact, you end up very quickly in a philosophical discussion of what exactly a type is. We could say, hey, well, the type of a value in Python is its class. But that's not quite true, because Python's a very dynamic language. You could do things like dynamically adding attributes to an object after it's been created. Even if things are the same class. I mean, dictionaries, right? These two dictionaries, we can kind of say they're different types. This has different items than the other. So what we actually do is we duck type our autocompleter. Our autocompleter doesn't particularly care about what class an item is. A value is. As far as we're concerned, these two variables have two different types. Sure, they share an ancestor, they have same methods, but they have two different types, and they will be autocompleted differently. There's a whole bunch more I could talk about the autocompleter. I could, again, talk about that one all day, but I'd like to take a break from this sort of whistle-stop tour of how Anvil works underneath and talk a little bit about the design philosophy, about some of the design questions of an abstraction this big, which is, first question is, what happens when that abstraction breaks? But first thing I'm going to do is I'm going to go and refill my water glass because it is a warm evening here in Cambridge, and I'm thirsty. I'll be with you in a sec. All right, we're back. So Anvil is an abstraction over the web. right? It lets you hide some of the complexity. But every time we use an abstraction like this, there's this question, what happens when it breaks? Every abstraction has its limits, right? The web is huge. We do not have every browser API in Anvil. We're never going to. They keep making new ones too fast. And this is a problem that all abstractions have. And when you're designing one, it's good to think about the failure cases. So let's start with an example of a different abstraction. Let's imagine you're writing, it's the late 1990s, and you're writing a desktop Windows application like all the cool kids are. And someone comes to you and says, I would like your application to be available on this newfangled World Wide Web thing. And you go, because that's really not something that the Windows desktop application is ever going to be able to do. Your abstraction, you've reached the limits of your abstraction and you are going down with the ship. You have two options. You can either rewrite your whole program on top of a different abstraction, which is very expensive, or you can sit tight and hope that that feature wasn't actually that necessary after all. And a whole bunch of companies died choosing door number B at the end of the 1990s. So obviously this is a suboptimal outcome. You really want to avoid this. If you're building an abstraction like we are, you want this not to happen. There are better ways of dealing with this. So of the web app people here, anyone here use Create React App? No, okay, right. So Create React App is it's a one-stop shop made by Facebook. It's for building. It lets you set up a new application with all the front-end build chain and Webpack and all the menagerie of build tools you need if you're building a modern web application with JavaScript. And it's kind of neat. It's got modules for all these common libraries that you can use, and it hides the complexity of using something like Webpack from you. But the problem is, sooner or later, you're going to need something for which there isn't a Create React App plugin, and you're going to want something more advanced. And the creators of Webpack have thought of this. They have a button you can push. That button is called Eject. And if you eject, Create React App will give up. You can say, I've hit the limits of my abstraction, drop me down to the lower level. And it will write out the Webpack configuration files for you and all your NPM stuff. And that's good, because it means you can get in there at the lower level and you can edit the thing and you can include the library you need. You're not stuck. You're not going down with the ship. But because you needed this advanced feature, you've now lost your abstraction. You are now down in the weeds with all the horrible gunk of a modern web front-end build chain. Because you needed one advanced feature, you've been dropped off in the middle of the Mojave Desert with nothing but a parachute and a survival kit and a copy of the Webpack manual. Good luck. So this is also a suboptimal outcome. What you really want is to be able to duck out of your abstraction without losing it entirely. What you want isn't an ejector seat. It's an escape hatch, something you can reach out of for a little bit, do what you want, and then go back into your abstraction. Python actually has great ones of these. So Python's abstraction over programming is very nice. Abstraction over what the computer does is very nice, but it comes with a performance penalty. And sometimes we want to do big, crunchy numerical computations. But that's okay, because Python has an escape hatch. You can build modules with native code in C. And so you can build a library like NumPy. And once you've built it, once you've done your screaming fast, low-level numerical computation, you can then wrap that back up, turn it into a Python module, and for the rest of your program, you're back in Python, you've still got your abstraction. So an escape hatch lets you overcome the limitations of your abstraction without abandoning it entirely, and that's very important. We have, believe in this strongly, we have escape hatches throughout Anvil. So here's an example, like the drag and drop designer. You can't design you can't do pixel perfect design with it. You can design within the parameters you're given. But if you need pixel perfect design, you can drop down into the HTML and CSS and you can edit it. But once you've edited the HTML, you can go back into the drag and drop designer and drag and drop things into this new design you've created. You've dropped down to a lower level, but you haven't lost your ability to go fast and use the abstraction. Similarly, you can drop down into JavaScript, write some JavaScript code, and then wrap that back up in a Python class that you can carry on using from Python. In fact, you can wrap that up in a library someone else who doesn't know JavaScript can just import it and use it. You can talk to other software. You've already seen the uplink, how, that's an escape hatch from I want to run server code that's not on the Anvil servers, that I want it to run somewhere in particular, access particular database or particular hardware. You can run it using uplink. Likewise, you can run it, you can use HTTP endpoints. It's even an escape hatch for the editor. I mean, I love the editor, I love the autocomplete, but somebody's gonna really want to use Vim or PyCharm, and somebody's going to want to be able to do other things to the code as, they want to be able to access the code as text files. Maybe they have continuous integration, maybe they have merge review tools. And so what we do is we expose every Anvil app as a Git repository, and you can clone it, you can pull it, you can change things, you can commit, you can push it back up, and the moment you push it back up, you can go and edit it in the Anvil editor again. Reach out of the abstraction, do something advanced, back into the abstraction with the full autocomplete and everything. So I'm going to close this out by talking a little bit about the why. I've shown you how Anvil does a bunch of the stuff it does. I've shown you some of the design concerns around trying to build an easier level over the web. But I'd like to close out by talking about the why, the principles that we kept in our heads as we were building all of this. And there are two principles I want to talk about. The first is that code is good. What do I mean by that? Well, you are telling a computer what to do. In about 70 or so years of computing history, we have not found a better way of telling a computer what to do than writing text in a programming language. It's as good as we've got. You periodically find systems that claim to be no code, where you can do all you want by dragging and dropping a flowchart, and generally speaking, that's a false promise. You will sooner or later end up doing something that the makers of the flowchart software haven't envisaged, and you'll either be completely unable to do what you want to do, or you can do it, but the flowchart you need to build is horrendously complicated and impossible for any human to understand. Either way, you find yourself sitting there, shaking your monitor, shouting, "Let me write the blasted for loop," because you know what you want to write. And so what we do is we have a system where you can get writing the blasted for loop as quickly as possible. Get you to the code. Remember, even the UI designer at the demo right at the beginning, I wanted to format a date. And I didn't click on it and use some GUI to describe how that date object should be formatted. No, in the user interface designer, in the drag and drop designer, I pulled up a data binding and I wrote a Python expression to express what I want. Because the code is the best way to tell a computer what to do. Code is good. Get me to the code. The second principle that we keep in mind all the way through all of this is to be accessible. And if you think, okay, let's make a tool accessible, you think, yes, 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 make it simple enough for novices. And don't get me wrong, that is an explicit design goal of Anvil. Anvil should be something you should be able to pick up with very little Python and make something useful. But that's not all of accessibility. If you make a simplified, dumbed down system that's simple enough for novices, but not powerful, you're doing those people a disservice. You are doing disservice both to novices and to the experienced professionals. You're doing the novices a disservice because you're not giving them room to grow into extra complexity and extra powers. And you're doing the seasoned professionals a disservice because, the web is an issue. The complexity of the web is real. Just because I can write 5 different programming languages to build my app doesn't mean I want to. But in order for me to be willing to use a system like this, it's got to be powerful enough that I know I can do everything I want to do. And this is why we make it powerful enough for seasoned professionals. The For starters, we have an industrial strength programming language, Python, in the middle of it. We have the full Python ecosystem. We have all these escape hatches so that you know that whatever you want to do, you will be able to do them by hook or by crook. And that also gives enough space for the novices to grow into seasoned professionals without dumping them out into the cruel hard world of JavaScript frameworks. And a lot of people's initial reaction to these goals is to say, yeah, that's a nice idea, but basically it's not going to work. There's no way to be simple enough for novices and powerful enough for seasoned professionals, especially not when it comes to something as complex as the web. And I really would like to strongly disagree with that. And I would say that we are sitting on top of the counterexample, right? It is possible to build things simple enough for novices and powerful enough for seasoned professionals because Python does it, right? The reason we are all, well, you are all in this room and I am in this office here, is the Python programming language. And Python is the language, the first language you will teach a 7-year-old at their first code club or Raspberry Jam. And Python is the language that DeepMind used to beat the human brain at Go for the first time in history. It is possible to be simple enough for novices, powerful enough for seasoned professionals. Python shows us it's possible, and it's only the terrible state of modern web development tools that makes us doubt it. And on that note of optimism, I'm going to say thank you very much for having me, and I'm very happy to take some questions.
Awesome. So I'm going to get up here and talk in the mic so that you can hear me. But for folks that want to, that have questions, I'll move some stuff. And if you guys can help us make a path here, you can come up here to the microphone so that our guests can hear you, and also anyone watching the recording of this. I'll start one off, and then you guys form a line. First of all, thanks so much for being here and doing it at such a convenient hour for yourself. We feel very selfish. I have a question about, maybe it's a feature question or maybe it's a design question if you have the feature, but kind of going all the way back to when you were showing examples of ORM style logic in your live objects. Is there a feature in how the app is run or apps are run that optimizes how those live objects call back to the server-side code? I'm thinking of like if I do something really naive, like writing a long for loop that increments the attribute on a live object, am I creating a lot of back and forth server traffic over the WebSocket?
Yeah, so you're creating. I think you paused. Have I lost you?
No, I'm here. Can you hear me?
No, we're back. Yeah. Sorry, I just the connection glitched. So yes, if you do that, like every call to Dundas set item, yeah, the square bracket assignment is a callback to the server. So if you write inefficient code, it will be slow.
Got it. Okay. And do you have issues with like race conditions of like the order in which those arrive over the WebSocket, or is that not a problem with?
Oh no, that is strictly ordered. We maintain that order for you. You know, we do this transformation of blocking code, and in terms of race conditions between different users of the same app. Of course, it's just Postgres, which on the back end, which means that we can, you can do with table transaction, and it happens in a properly isolated industrial strength transaction.
Got it. Okay, thank you.
Howdy. Okay,
Hi.
so I have a lot of questions.
Go on.
Oh yeah.
We may need to take turns with other people in the line. So ask one or two and then go to the back of the line and we'll take turns.
Okay, so the first thing is given like a dynamic web page, exactly how much of it is client-side rendered and how much of it is server-side rendered?
So everything that's built in the designer and in the constructed by your Python code is client-side rendered. So the designer, just to be clear, that drag and drop designer is just equivalent to calling a bunch of Python methods and instantiating a button and then adding it to this point. So that code just runs as the as the page opens.
Right. So like a basic CRUD application, for instance, somebody manipulates something. Does the backend have to re-render the DOM and pass it forward, or does
Nope,
it?
no. It's all that's why we compile the Python to JavaScript. It's all happening locally in your browser.
And you said that instead of using REST, they're just like RPC calls over WebSockets. Does it have to instantiate a new WebSocket connection for every call, or is it just one solid?
No, it's a live. So when you open when you open the web page, it makes a single connection and then runs all the.
Does that impact scalability at all? Because that would mean you would have to have, for everyone using the site, there would have to be an OpenSocket connection that is consistent and persistent. Is that
yes? So that's yes. Load balancers are a thing. That doesn't really incur much load until you actually send a connection down it. Honestly, with the modern HTTP keep alives, the browser would be keeping a socket alive anyway for the HTTP requests, so it doesn't cost us any more, but it allows us to do things like those strong ordering guarantees we talked about in the previous question.
Gotcha. And I take it you guys recover from like a socket connection breaking or anything pretty gracefully?
Yeah.
Okay. And the last two questions. So how exactly is the Python interfacing with the database? You were talking about how like ORMs a lot of the time incorporate some like weird black magic. What are you doing to kind of...
Yeah. Okay. So now this is a really good point, but it's subtle. The API that is exposed from the data tables, it is database shaped, right? They are Python objects, but they are rows. They have values. You can update them. They have links to other rows. We don't try to make them act like Python objects, right? The thing that makes SQL Alchemy black magic is the subtle mismatch between how database rows operate and how objects operate. And what we say is we don't try and make that thing. That we don't try and make that conceptual leap. The thing that you pass there is actually database row shaped, and it behaves like a database row.
Right.
And so there's an awful lot less magic.
Transition.
Right? You could implement the server side part of a data table or live object, data table live objects in like a tiny number of lines of code of Python.
Gotcha. Okay. And the last question is, why did you have IntelliJ open?
Over there. Because the API router is in fact runs on the JVM.
Okay. Yeah, I just saw that and I was like, huh.
But I mean, also like IntelliJ, it's all the same thing, right? IntelliJ and PyCharm. So I actually have two windows open right now.
Please tell me you're not writing Python and IntelliJ with a plugin.
Yeah, well, so one of them is IntelliJ with the Python plugin, which is basically PyCharm, and the other one is IntelliJ with the Clojure plugin, editing our API router.
All right, well, that's all I got. Thank you, man. It's a really cool product.
All right, next up.
It looks like that was all of our questions.
Excellent. Well,
thank you again so much for joining us.
Well, thank you very much for having me. I hope you've enjoyed it. As I say, everything I did in this presentation is available for free at anvil.works. So do try it out. All you have on the free account is a banner on the top saying "Made for free with Anvil." But you can use the uplink, you can use the database, and yeah, go try it out. Thanks very much for having me, and drop me a line. I assume that my email address is around here somewhere on your event invite, or can be sent around.
We'll get it out to everyone.
So if you do come up with any questions and you were just too shy to stand up in front of the microphone, do drop me a line.
Great. Well, we're going to hang out here. You guys are welcome to hang out and mingle a bit. Would you like us to leave you up on the giant screen on the wall while everyone mingles so you can just look over them?
That feels extremely big brotherish, and what's more, it's 10 to 3 over here, so I think I'm going to turn in.
Get some sleep.
Absolutely. Thank you very much for having me. It's been great. You guys have a great rest of your evening.
Thanks so much.
You too. Thank you.
Bye-bye.
what kind of raffle to do.
Yeah.